power this computer. And I think we should start. Nice. All right. So today we're going to talk about basics about MSI setup and let's share basics about MSI setup. And I'm going to first go over an overview of what it is, the general workflow, and then we're going to go into the details of how to actually submit a job and run scripts on there. All right. The first thing before we do anything is to get VS Code and to get a VS Code extension called Remote Explorer. This just makes our future connection with MSI easier because it remembers the host name. And also it provides us with a graphical user interface instead of the terminal interface or the command line interface. For anybody who hasn't downloaded Visual Studio Code yet, this is the link. You can follow this link to download Visual Studio Code on your own computer, right? And then after you download Visual Studio Code, the next step is to go to Extensions tab and go and find Remote Explorer. Where is it? Did I type Remote Explorer? Yes, here we go. That's the one we want to install. And after we install this extension, this makes our future connections to MSI servers much easier. Right. Now we can go back. While this is setting up, we can go back to the main content. So first, what is MSI or Minnesota Supercomputing Institute? The part of it, they offer various different services. The part of it we're going to focus on right now or today is the high performance computing they offer. Um, on the right is like an explanation of how things work and why this was necessary and how you would normally connect to a MSI server. Something to note that is you do have to be on campus or connected. If you're off campus, you do have to connect to a UMN VPN to access any of their services. Right. The next thing we're going to talk about is some terminologies that MSI introduces. The first one is clusters and partitions. Um, those are there's many terminologies they have. We'll introduce them one by one. For clusters, we would have let's see. Yes, we would, for example, at first, the MSI, the institute, they would buy a bunch of GPUs, and then they would maybe create one place to hold them. So now all of this place with all of those GPUs, this becomes one plus cluster. Well, maybe 10 years later, there's new GPUs coming out, and they want to buy some new GPUs. In this case, they don't want to throw away all the previous ones, but maybe the previous location or the previous environment conditions were not suitable of holding those new GPUs, or the power supply were not suitable for holding those new GPUs. So they buy new GPUs and they will store it at a different set or different location. So then now you have two clusters. And you can imagine as time proceeds, when they buy new GPUs and when they couldn't put them all together in one place, the different places they put them, now we have three clusters of GPUs. For MSI, they do have actually three clusters. This is not the picture from MSI. These are online pictures. But those are what clusters mean. It basically just means a bunch of GPU all together. And this is more of the but this is more important to the MSI teams because they group all of those different and the GPUs in one cluster, they don't necessarily have to be the same GPU. You can have A100 and V100 all in one cluster. This is just they've decided I want to start this cluster. I'm going to buy some GPUs. Now they become one cluster. Yes. And now partitions. Clusters, one cluster, say we're taking this cluster, it would have many partitions. For example, this column would just be a partition for V100. So all of the GPUs in this column, they're V100 GPUs. And this column might be a column for A100. So you have many, many partitions in a cluster. And to make it even more confusing, there are nodes in a partition. We've discussed that one partition is a collection of the GPU of the same type. And of course, they can buy multiple GPUs of the same type. So now each individual GPU becomes a node. We will later see that we can refer to which partition we can connect to a cluster, which is we can, because those are likely hosted but in different internets. We can connect to a cluster. We can select which partition we want to be in. And then we can select specifically how many nodes in the partition we want to allocate to our program. Yes. Um, introducing, those are general terminologies, introducing us to MSI specific names. There are 3 clusters in MSI, and I believe recently they've merged the first 2 into one federated partition, a federated cluster. So now we have 2 main clusters. One is the A-gate cluster. This is their latest cluster with very great GPUs. And the previous 2 are clusters that were way before, and they still have some decent GPUs. But if you want to do very high performance computing, you can connect to the A-gate cluster. Right, and the connection process is all the same. We'll show it later. We'll do a code demo of how you can connect to them. They're pretty much the same. You just replace names. Yes, and what we're going to talk about next is this is just a sublist of all the A-gate partitions. If you want a complete list, their official website have a complete list of all of their partitions. And at the end, we're going to take a look into what are some interesting names like interactive, preempt. For now, just ignore them. And for example, A104, this is just A100 GPUs. Yeah. And we can see this is exactly what we like to see. If we've trained our notebook in Colab, this depletes our compute units very, very fast. And with MSI, we have sort of unlimited access to A100s. So that's great. And something to note that's particularly useful is that apart from just boosting efficiencies, there's another reason why you would want to switch GPUs is that each GPU has their own GPU memory. Sometimes when your input text is too long or your model is too large, you would face the error of the GPU or CUDA memory. You run out of CUDA memory. In this case, that is the time to switch a GPU or to decrease your batch size or to somehow truncate your input. Nice. Next, we're going to walk through a demo of how to connect to one of those MSI clusters. Um, First of all, if you're on Windows, are you on Windows? No, that's nice. If you're on Windows, there's a complete guide of how you have to follow the complete guide of bringing you into a sort of Unix-like terminal so you can connect to MSI. But if you're on Linux and Mac, all you need to do is you would open up your terminal, you would type SSH, your username, your internet ID, and the name of the cluster. In this case, we're connecting to the more efficient cluster, Agate or Agate, and .msi.edu. After you type in this, it will prompt you to enter your password. And then in this case, it doesn't prompt me because I've set up my SSH key, but it should prompt you to enter your password. This password is your UMN password. After that, you have to do dual authentication, and I'll type 1 and I'll receive a notification on my phone. And now we've logged into, after a while, yes, now we've logged into the MSI computer or the A-gate cluster of the MSI. We can see if we try to see where we are indeed in the MSI server. Another way you can tell is that this is the server name. So I guess I am on the A gate cluster, and 104 is just some of the login nodes they've maybe assigned me, or some nodes they've assigned me. This doesn't matter too much, but you can tell that you are connected to the server in this case. And so this is a little bit more complicated because each time we want to connect, we have to remember what to type, and then we have to type our password. There's two ways, there's two steps we can simplify this. First step, and also we couldn't, it's difficult to navigate through the files because it's just a command line interface. That's why we have the previous extension VS Code. You would type exactly the same thing over here. You would establish a new connection. Here you would type SSH, your username, and at agate.msi.edu. That's exactly the same what you would type in the terminal. But after this, and you go through exactly the same process. They would prompt you to enter your password, and they would prompt you to do dual authentication. But after this, once you establish the connection once, VS Code remembers what commands you need to run, and you have a great list of servers you can connect over here. In the future, you just need to connect through clicking this arrow, whichever arrow you want. And then it will connect you to, I should maybe disconnect and show everyone. No. Yes, every time Zoom is getting in my way. Uh, every time you reconnect, uh, you can have a graphical user interface of all the files you would have. And then you would also be able to skip the memorization of what's the server name. Great. Yes, and now we're going to get back to the slides. A side note here, uh, you must be connected to campus Wi-Fi or UMN VPN. And also you can sort of further simplify your life by setting up a SSH key. This is not the priority today, so we're going to talk about it at the very last. But yes, you feel free to follow this link, and there's a complete tutorial from MSI of how to set up your SSH key so you don't have to type your password every time. You still have to do dual every time for their security reasons. Nice. Quick slide of how much storage you'd have. You'd have 150 gigabytes of storage on in your home directory, so that's more than enough. I believe so, yes. Every person got 150 gigabytes. But after the semester ends and after semester ends, when the course completes, they would remove everything. So anything for this semester, you can store it over there, your model weights and everything, but don't use it as a permanent storage platform because they will be deleted after semester. Nice. Now we're going to go through a quick dummy prompt of how we can submit a job, or we're not going to submit an actual training job because that's more complicated. That's going to be our next step. At this step, we're going to walk through we're just going to get familiar with submitting jobs to MSI. So in this case, let's ignore the project. Normally, we would already have our project script, like our train.py that we've wrote. Right now, let's skip it for the moment. And then the next thing is we're introducing the Slurm script, where this is, let's see, there would be first of all, why would we want to have those whole complicated procedure? Couldn't we just run our train.py directly through the terminal interface? There's the issue with this is that there's like thousands of people submitting their jobs to MSI every day, and it just wouldn't be enough GPUs or enough resources. Say everybody wants 8 GPUs, they just wouldn't have so many. So Slurm is it's the thing that does the scheduling job. So for example, if I've submitted this for 10 times a day. And we're going to get into how it's fair at the very end. But basically, it's just a scheduler that determines when your job is going to be run and make sure when your job is run, you do have um, all the resources you requested. This is a simple Slurm script we would have. And oh, and I think I should. Oh yeah, I should. 1 second. Let me upload this onto a Git repository so it will be easier for everybody to download. Let me. Oh, nice. Now we're walking through a GitHub repository setup. This will be within 5 minutes. Mm, public. Eh, Nice. Let me clone it over here. Let me add all the scripts I would need, copy all the scripts I would need over there. Good. Add it. Oops. Right. Now everybody should have that. And I have to copy the link, of course. Let's see. Good. And where do I put this? In the slides. If you go down a few slides, there's over here, you can clone the GitHub repo. And for nice. Okay, now everything's set up. Let's go back to the slides. For here, since we're just doing a small script, and I'm going to walk through it line by line, so we can just copy and paste it, or we can just type it line by line. We've gone through why we would need such a scheduler, or why would we would need to submit it in a specific format. And of course, for this scheduler to understand how much resources we're acquiring or we're requesting, and how long we should be running our process, and when should it run our process, all those information. This is incorporated in the Slurm script. Um, I'll first go through what each line means, and then we're going to type those into the uh, we're going to create the Slurm script on our MSI machine, and we're going to try to submit a job. Nice. The first line, this is just telling Slurm or telling the machine to run a bash shell. And after you got a bash shell, uh, all the lines of code that starts with hashtag or pound sign as batch, this is a specific Slurm directive. Yes, this is all the you would have multiple lines in the future where you would have one line saying that this is our job name. We want to name our job as just demo1 or whatever name you want to name it. And maybe you want to request how many GPUs you want, how much time you want to run on those GPUs. We'll get into those very shortly. Right now, we know that there's the three main component. There's the first component that you have to have. Do not change this at all. And then this, you can change it with whatever job name you want. And then at the end, this is the program we actually wanted to run. So now we've requested for all the resources. And now we say, oh, okay, I want to run this simple script. I just print out, I ran on a node, and then I want to see which actual node I'm running on. And then we're just going to simulate some training. We're going to sleep for 20 seconds. And we're going to try to submit this to MSI and see the results. So the first thing, this is a bit messy than what you would have. You wouldn't have those two folders when you just connect to MSI. The first thing, of course, is to create a script. It doesn't really matter how you call the script, but it is good to call it something, your script name and then .ask batch. Even if it's not ask batch, it will still work actually. Um, and then you would run those few lines. Again, this is connecting to a bash shell. This is information you want to tell the scheduler about your job information. And this is the actual script you want to run. Now we want to submit the script. We submit the script by typing s batch. Oh yeah, I cannot pronounce s batch. S batch, and then just the. I have to go out. We'll do as batch, and then we'll do just the script name. So submit dot as batch. Right. And here you can see we get the information saying that we're setting up things and we've successfully submitted the job. So now the job is kind of on the machine or given to the scheduler, and they will decide when to run our job. So how can we see what status are we in our job? We would type SQ and me. This is just, there's so many jobs that's being scheduled. I just want to see the job that's related to me. So, well, now we see that this is the job that's related to me. I have not, did I start yet? Nope, I have not started yet, and I'm still waiting for it to allocate resource for me. Without specifying any GPUs or any time, um, uh, it is able. There's some default settings that Slurm would give you. The default setting is a random GPU partition, and also with just one GPU, and then running for 1 minute. So yes, we are not requesting for a lot of resources, and we should be able. Yes, now you see that it is though it is still not run, but it is in priority, which all those concepts we're going to explain later. But I hope this makes sense of a general process of how you would submit the script. You would have your own script, you would submit it to MSI, and then through Sturm script, and then you would just monitor its status and view its output eventually. Um, and view its output eventually when it finished running. Right. While, oh, let's see, is it finished? Nice, it's nearly finished. Good. Um, so now we see that our program has finished running. And then, so now when we look at what's queued for me, I don't see anything else. But however, oh, actually, and it provides the output without, yes, and it provides the output. This is the output my job got this is the output from the job I ran, which is exactly I ran on Node, and then this is the output of the command hostname. Right, that's great. Now let's go back to now let's go back to the slides and uh and going to more detailed how we can actually submit a PyTorch training or Hugging Face training loop to MSI. Before we get into that, there are some things I want to mention because not every time you submit your job, you would be successful. Sometimes you would have weird errors. Here's a list of what it means for each of the error. You can see there's or not even not error exactly, but your job status. You would have pending job, you would have completed job, you have a job that you cancel, or you would have a job that is currently running. Because our previous script was so quick, I don't think it even appeared. But those are the symbols MSI use to represent the different states of your code. Right. Now let's actually go into a a full PyTorch training. Oh, actually, before we go in, just to reiterate the process, you'd have your Python script, you would write your Slurm script, You just submit it with Ask Batch, and you just check the status with SQ. Nice. Now let's go into writing a full Hugging Face training script. First of all, of course, we have to get the script. I've already written a testing script from the GitHub repo. You can you can click the link to clone it, and after you clone it, you would see this intro tutorial. Um, so first, let's cd into our intro tutorial. Uh, intro tutorial. All right, so now we can run things. And now we actually want to write the, let's see, shall I discuss about the script first? Let's briefly go over the script. There's nothing too fancy. This is just a standard Hugging Face training loop you would have. But because there's so many parts that could go wrong, I've breaking them up into different functions. So we're running each part one by one. We have a better idea of what goes wrong. After we go through the setup process, we will just run the code and see if all the tests passed. And this is because when we log into MSI, when we log into the server, we are only assigned a CPU, but not a GPU. We have to request the GPU through the Ask Batch or through Slurm script. So if there's anything related to running on the GPU, we couldn't necessarily test it on our in just this terminal because in this node we do not have any GPU access. The only way we could test it is to submit the job, is to already write a GPU code. You can see there's a train CPU and train GPU. Is to already write the GPU code that trains on GPU, submit it to MSI, and then according to the MSI results, we can analyze the results. And if there's anything that goes wrong, we go change the code, we go submit it again. So this is you wouldn't want to, you would maybe want to run this for just one training step on your collab first, or on your local computer first, to make sure everything's running fine, and then submit it to MSI because it's pretty difficult to debug in MSI. You have to wait for your job to be run, and then you have to wait for it to be run, and sometimes the output are not so friendly. And there is a way to get around this where you could have a MSI Jupyter notebook. So you can actually connect your Jupyter notebook that is interactive and has access to GPU. But that's more advanced. That's more than what we would normally need. I will include that in the end. Getting back to submitting scripts to MSI. Um, Now we got the script. We finished running the script. You can trust the script. It is running. I've run it on my local computer, and now it's the actual MSI part. How do we write our Slurm script? How do we request for resources? This is a kind of a standard full Slurm script you would see, and this Slurm script this Slurm script consists of three main parts. The first part, as we've discussed, is just to say which shell we used. I wouldn't imagine any case you wouldn't use bash, but maybe there is if you're doing advanced stuff. The second part is requesting for resources. This is we're going to dive into each of them. I just want to go over the high level first. The second one is requesting for resources. All the Ask Batch must be at the front of at the very beginning of the file. You can have empty spaces between them. You can have comments between them, but you cannot have, say, a CD script in them. The Ask Batch or the Slurm script stop to how do I say this? They stop executing any S batch script when they see the first line that is not an empty line or a comment line. And to slightly distinguish between comment and this pound S batch, if you have a comment line, you would actually have an extra space in between here. And for an S batch directive, you would not have the empty space between them. All right. Oh, and the final part. the final part, this is what we actually want to run in the cell. We can have some once we submit the job and the job starts running, um, it starts kind of fresh new, just like if we've just logged in to MSI. So we'll be at our home directory. If you want to do any change of directory, you have to do it over here. For module load, we're going to explain more about why that is the case. Because we're in a fresh new MSI directory, it kind of just have absolutely nothing. Like it wouldn't have the CUDA drivers, it wouldn't have Python on it, it wouldn't have any package manager. You have to manually download them, or in this case, load them. Load is different from download. Load is better because MSI has already pre-built a bunch of binaries that you would need, or a bunch of softwares you would need. You can just simply load them if you know their name. So we would have to load all those packages into the bare bone MSI, and then we can actually run stuff. Great. Now let's go into the requesting for resource part. For this part, first of all, we have to find, we are now at the A-gate cluster because we've logged into A-gate. But still, we want to know which partitions you use because as we've said previously, there's different partitions in, or you can think of them as different GPUs in one cluster. Here's a complete link of how many, what partitions you would have in A-gate. The image we've shown before is this is just a screenshot of part of the GPUs or part of the partitions. And then after you decide which partition to use, for example, in this case, I decide I want to use the V100 partition. So now uh, it knows that, okay, I'm going to go to this, or it's pretty self-explanatory. This is just saying I want to use the V100 partition. Anything I execute after this, the GPU I requested, they're all going to be nodes in the V100 partition. And after you specify the partition, you want to tell it how much resource do you actually want. And do you want to store the output, the terminal output, which is standard output, or the error logs anywhere, or do you just want to ignore them? Um, so we see over here after we submit the partition and of course our job name, you can name this whatever you want. The three major things you want to specify, or three major resources you want to specify. First is how many GPUs you want. This is uh, everything up to the equal signs. There's strict syntax that you should not modify. So this is saying this is just a flag saying I'm requesting for GPUs and how many GPUs I want to request for and what type. This part you would say GPU, the GPU type, which is V100, and then you only want to request for one V100. Different partitions have different GPUs. So for different partitions, you would input different GPU types. And for different partitions, there's the maximum number of GPUs you can request for. Um, and if you're requesting for one, you're always fine. But if you're requesting for 8 GPUs, you would have to go to the link to see there's a detailed documentation of what's the maximum amount of GPUs you can request for that partition. The next thing we want to request for is this is the RAM we want to request for. In this case, we want 30 gigabytes of RAM, and we also want it to run for 5 minutes. Those are the three major components or three major resources you would specify how much you want to request. And after this, this is just an additional line saying, well, for all of the terminal output, I want to output it to this specific file so I can view it later. If you don't specify the output, as we've seen with the dummy script before, you can still get around with it. But it would always be, it's just not so organized. You could actually get around with it and it would print out if you look at the file just now, I didn't specify anything in my SBatch how I want to run, where I want to store the file, but still it gives me an output file. Yeah, I'm not sure if anything would error if you have longer output files, but it's always better if you have a dedicated space for it. one additional tip or trick. This percent %J uh, just says because your job would have your own unique job ID, and the percent %J just says yes, append my replace this percent %J with my job ID. Or you can think of this as a F string and your this is the format string and this is the format string and your passing in the job ID and then it will replace this percent %J. Yes, those are not the important part. The important part is request choosing partition, requesting for GPUs and memories, and specifying how long you want to run. For the maximum amount of memory and time, this would also be specific to your partition. You can check it out in the specific link. We're going to go through it at the end, but normally if you're requesting for something like this and for an hour, things will be fine. Nice. The next part about loading software into modules. So now we finished this first part. We've determined how much resource we want to allocate, and we want to actually run our script. But because MSI is so bare bone, when you just start a new session, you have to load all those packages you need into MSI. There's a complete link of what all the softwares they have, like Python 3, Python 3.2, Python 3.3, all of the different softwares they have. You can search in this official link. In our case, we're just going to load three specific packages. Just Python and Anaconda. It'll be better with a code. Let me explain it with code. Um, we'll just be loading. Here we go. Yes, I have the code. And in our case, um, we will just be loading those three modules. The first module is GCC. The second module is our Python with a specific Anaconda environment. And the third one is the CUDA driver. If you do get any errors regarding, nope, you shouldn't get any errors regarding this. If you do get any errors, I guess contact me or maybe even MSI. This is not a step that should error. Um, yes, if you just run this step, let's go into the code demo of running this step. Let me unload everything. Uh, yes, now you can see if I want to do anything, for example, if I want to run conda, I okay, I've did some configuration where it automatically does something for me. But normally this wouldn't succeed. You wouldn't, I should make it bigger. Yes, normally this wouldn't succeed. It would tell you conda does not exist, and you would have to load all those packages yourself. So you would copy this, just run this in the terminal. If there's no output, it means everything's fine. And we can here's in the previous slides, there's the list of all commands you can run. You can list all the you can list all the modules. You can see what's available, what modules are available. And you can also just download all the modules. And you can also see a documentation of what one specific module does. Um, I find those three modules to be pretty uh, comprehensive. You wouldn't really need any other modules. But if you do end up wanting to load other modules and you want to see what are the available options, you would type module avail. This will list all the modules. So typo. This would list all the modules. It will take you quite a while if you want to scroll through this. Um, and All right, you exit it by pressing Control C, or Command Control C. Yes, this will take you quite a while. So, three ways to work around with it. The first way is to just go to their official website to search, and then after we can actually go through a demo. Um, is to go through their official website to search for any packages you want. For example, Python, and then you can find that there's those Python packages that you can load. You would copy, you would you would copy the module name and then do a module load over here. But in this case, because I'm loading a different conda version than the default conda version. My load was a little bit more fancy. If you see over here, it's a it's a quite long module name instead of just conda. Um, this is the first way you can search for the software you want to load. The second way you can search for it is the previous output is too large. Where is it? Yes, module available. This gives us such a long file, and the terminal doesn't output all of the files, all of the content. So we could do something, which is redirecting the output. This greater sign means redirecting whatever gets printed to the output into a specific file. In this case, we can redirect everything this command would output to our, say, module list.txt. And after we run this, everything the terminal outputs, this is going to be um, all printed or all written to the module list.txt file, where it takes a while for VS Code to update. Yes, and if you write a file and you don't see it, try refreshing your VS Code, and in a minute it should. Am I? Yes. Wait. Let's see. Yes, I do have it. Oh yeah, here it is. Now you have a very long complete list of all the softwares, and searching through here is easier. You can search for Python and you see all those different Pythons. Nice. Let me remove the redundant file, module list.txt. All right. Now we've talked about how to load softwares from how to load the softwares we need from MSI. The next step is that since everything is or you might have your project and homework all running on MSI, it is very important to separate your environments, which is why you would want to use Conda. And you couldn't directly use Conda. You'd have to type Conda. If you directly use Conda, it would tell you a bunch of errors, and it would tell you to use Conda init. After you type Conda init, and you would have to tell it which shell are you using. We're using the bash shell, or we wouldn't be using any other shells in this tutorial. And it's the most common one. Um, we would type conda init bash, and after we type this, this would um, uh, I should do it step by step. After we type this, we would conda init bash. After we type this, we can use conda as we like. We can type conda activate or stuff. We can conda create new environments, and that will be just the same as the previous conda tutorial of how to create environments and stuff. Um, because I've already created the environment, I'll just directly activate it. Conda activate MSI tutorial. This is the content environment I've created. Things should be activating successfully. And if you again see the message, try to do conda init bash again. What it does, shall I? Yes. What it does under the hood is that this part is non-relevant to submitting jobs to MSI. But if you're interested, that what it does under the hood or why it fails previously is that it adds an few extra lines to your bash RC file. The bash RC is kind of like the file you would run every time you launch a new shell session. So before, when you type conda activate, it wants to make your default Python path to point to the condas environment's default Python path, but it might not have the enough access or enough privilege to do stuff, or just not have all the path names. So this part is what you would have after you type conda init. It just injects this bunch of code in there. And after this, you can type conda activate and everything, and they all work fine. Great. Going back to our code, we can now try to run the not dummy py file anymore, but the test train file or test train file, the train file to see if everything, to test if everything is working correctly, right? So we would cd into our directory, intro. Oh, I should do it the same as what you would clone MSI tutorial and intro tutorial. We will cd into it, and then we would try to run the script by saying Python train on CPU.py. Oh no, this is expected. Uh, Python was not expected. Yeah, maybe there was something going wrong when I tried to unload all the modules. But well, doesn't matter. We would just use Python 3 right now, getting more interesting behaviors. Let's try to run Python 3 with the train on CPU.py. Because there's so many things you have to configure on MSI, it is good to first have a test file to see if everything's configured correctly. This part, we see that, and that's why I've broken the train file into different parts. This file, you can see, in this case, you can see it fails the first test, which is trying to import files. Because of course you have to download everything on your, you have to download all the libraries. Yes, and we would go and try to install Torch, install data sets, and is oh, let's see. Let's install transformers, which I think automatically helps us install Torch with the correct syntax. And we also want to install data sets later. Uh, and we have to type pip3. Oh, good. We wait for a while, and while we can search up the syntax for installing data sets, I believe, oh, actually, you can just type pip install dataset. Torch is the one that's weird that you would need specific install syntax. Oh, this is, am I using the correct syntax? I am. Oh, this is getting more realistic of what you would actually face in an actual MSI setting things up. This was an unexpected bug, and I did not have it when I tried to set things up, but now there is. Um, let's see how we can fix it. Uh, which Python are we using? Which Python 3 are we using? Oh, that's an issue. I don't think our conda is well. Let's try restarting the terminal. Python. Okay, we do have Python this time. CD MSI setup tutorial, intro tutorial, and let's try to run Py. Oh, I might know what the issue is. Then let's try to run Python. I'll not activate the virtual environment yet. I think the issue is when I was um, creating the virtual environment, I didn't specify the Python version, so we don't have the correct Python version. In this case, the base environment of Conda is 3.10, so we should be all good. Let's try Python train cpu.py, and here we run the import test. and see if it works. Yes, now it works. This works because I oh good. Um, this works because I've already typed pip install transformers, datasets, and PyTorch already in this base environment. If you face any import errors, you would just do pip install. Um, and now we see that it's taking some time and running on the CPU of an actual simulated training loop of training our model. We have a pretty small input data set, I believe. Our input data set is just, I cannot see because of Zoom. How do I make Zoom go away? I can't. Um, if we look at our train CPU script, we're just taking only the first three samples from the whole train data set, and we're feeding in a batch size of 2. You always want to feed in with batches instead of just individual data points, because eventually when you run on a GPU, you would specify a batch size, and things might go wrong when you didn't have a batch size, but you suddenly add in a batch size. Yep. And actually, something else that's worth noting is that this is not, again, not related to MSI, is that you do have to change the number of labels over here, because the model, when you load in the model, you have to tell it by default, it predicts just 0 and 1. Or this specific model, by default, it just predicts 0 and 1. But in this case, we're classifying between four categories. So you do have to specify your number of labels over here. If not, your model would break and you would see error when training your model. Great. So now we've tested everything. Our environment's working fine. Our packages are working fine. Everything's working fine locally without GPU. Now we want to submit it. We want to submit the job to the MSI server, or we want to change the code to use GPU and then submit it to MSI. So here we would submit the train.gpu.py, train.gpu.py. This is exactly the same code, just now that we're using the CUDA device. Um, oh, um, one thing to one thing to note is that every time because every time we connect to MSI, it gives us a fresh new session. So what we can do is that, and we would have to do module load other modules all again. What we can do is that we can modify our bash RC file, and we can add the line below. This comment should be in the file already, but you wouldn't have this line. You'd have an empty line over here. You would add the line over here. So in this case, every time you connect to MSI and it runs up a bash shell, it loads the module automatically for you. So you don't have to remember this line and do it every time. And again, also, if you have any API keys or anything, Hugging Face API key, OpenAI API key, you can also export them over here so you don't have to manually do it in your script. Nice. We've gone through loading the environment, and now let's see how we can submit the job. And we're quite confident that the train GPU, since the only thing we've modified is moving it to GPU, it should work fine. There's no way of us testing it because we don't have a GPU, but we've tested as much as we could. Now we're going to how we can submit and monitor jobs, or we can monitor the jobs. The first step, of course, is to submit our job. So again, we would have to, when we submit the job, remember we have to configure the Slurm script to tell how many resources we want to allocate and what command we want to run, which was done by us already. We need the actual script to run, which is also present. And note over here, in our bash script, this wouldn't work on your computer because I have a directory. This is just saying once everything's loaded, once I have all the resources, what should I actually run? In this case, I am changing my directory to intro tutorial, which you would not have, and then running the train.traingpu.py in that directory. So what you would do is that from the home directory, you would change into Oh no. You would change into MSI setup directory, and then in that directory, you would have the intro tutorial directory, and make sure to not make any typos over here. You would change into this directory, and then you would tell Python to run this train GPU.py. Um, this line of code is also something I added just to prevent some weird issues or bugs and to make sure your GPU utilizes as much resource as possible. This line is just, I want to make sure that I am using the Python from the content environment because that's where I have the path to all my installed packages and dependencies. So this is just more of a debugging command that I run to see if anything goes wrong. Is it my environment's problem or is it my script's problem? Nice. We have this bash script. Nope. We have this s batch script. And then now all we need to do is to submit it, which is let's type as batch submit.asbatch. This would submit everything to MSI or submit your job to MSI, and MSI would determine, well, when does your job start running? You can again use the SQ command and followed by me. If you just use SQ, it gives you a long list of all the jobs that's submitted. You can use SQ me to see um, how is your job doing. In this case, two things. In this case, we can see that it's likely not started yet. From many indications. Let's break this down. The first, and let's make it bigger. Yes, if we look at a typical job submission, there's several fields of it. The first thing is your job ID. This is if you want to cancel your job, you would type as cancel job ID. This is just saying, well, you submitted a job, it has to assign us some ID. Which partition you're running in, the name of your job. This is specified in the, if you remember, in the bat as Slurm script. Over here, you define your own job name, and then the user that submitted it. ST. This is, if you remember the previous slides, this represents your status. Here, oh, what does ST do? Oh, not ST. ST is the status, and the actual status is PD, which is saying it's still pending. You will see different status once your program gets canceled or run. And um, the next thing is, let's go back to the slides. The next thing is how much time your program have run. In this case, this program has started. In our case, our program haven't started yet. How many nodes you're requesting for, and then uh, if you're in the priority or not. And then if we look at the SQ again, we can now see that it is now being run. So it's on node list, uh, the agate node list at this node being run so much time, and it has a status of actually being run. Nice. If we want to cancel it, we would copy the job ID and we type as cancel. And after our program's finished running, which it hasn't, oh, now it's finished running. Um, After our program has finished running, we can there's multiple ways we can inspect how our program was doing. The first way is that we can just go to our output file. We specified an output file the model should output, which is where is where is everything? Yes, here we go. What's this? I don't think so. Where is our output file? Job log, test transformer. We would go into, oh, here we go. We would go into test log, and here we see this is the output of our new script. You can see that indeed the weights are uploaded, the weights are updated, so the training went well. There's some warning messages which doesn't we don't need to care at this particular warning message. We don't need to care. And we can also see that the which Python we printed out. This is indeed Python from Anaconda. So everything's working great. And this is the total time the script takes. So great. Everything's working well. If you want to gain more insights apart from just the output, for example, you want to wonder how much, if you want to increase your efficiency, you might want to determine what's the bottleneck of your efficiency. Is it the CPU that is too slow? Is it the RAM that is preventing everything from given to the GPU? Or is the GPU that is not being fully utilized? Or is the GPU is just it's already fully utilized and you should request for more GPU? The command to do that is by running sef and with your job ID. If you run this, it will give you a quick summary of what happened or your whole job training process, your whole job process. You can see we've utilized this CPU for only 3 seconds. The efficiency isn't very high, so the CPU is definitely not the main bottleneck. And we can see that neither is the memory. The memory we aren't we're not really using it at all. So yeah, this is just another helpful command to help you determine your uh, hardware utilization. Nice. Going back to the slides. Now we went through the whole process of submitting a job, um, where first we have to create our project script. We test it locally, everything works fine. We try to test it on the CPU, everything works fine. Now we create the Slurm script, um, which specifies what resources we want to allocate. We want MSI to allocate for us. We submit the job, and then we just wait for MSI to run the job. We can check the job using SQ during the process. We can cancel it if we find any errors. And eventually we view results by seeing the output file and also using SEFF to see the utilization. Nice. And then I think this is where, yes, this is then the complete view of how you would submit a job to MSI. We would take a small 5-minute break while I answer any questions or solve any bugs if anybody has any. And we will come back later with some more advanced MSI features or with more explanation of how MSI actually works. Nice. All right, let's get back into the slides again. Um, Here we're going to go over some useful MSI tutorials or useful MSI tips. The first part is we mentioned that we have the Slurm scheduler, and how does it actually work? So there's some sort of notion of job priority under the hood, where they would first run jobs with higher priority, and then they would run jobs with lower priority. And your priority is determined by three factors. If you somehow remember before that in our when we type SQ, there is there is this node list. If it hasn't been assigned to us, sometimes we do see a priority over here. That means our job is in very, very high priority, and it would try to run our job first. Um, Three main factors that impacts your job priority. The first one is age. The longer time you wait, if you've waited for 24 hours, you would have higher priority than somebody who's used exactly the same resource as you, but just submitted the job a minute ago. The other part is size. Actually, the larger your job is, the better it is that is prioritized. Are you here for the 55? Yes.
Don't worry, I'm housekeeping, waiting my time. Okay?
Oh, sure. Yes.
Don't worry.
Yes.
Nothing, I didn't start.
Oh, yeah. Um, over here we have job priority, which is I've gone to the longer we've waited, the higher the priority, and actually the larger your job size, the better your job is actually prioritized. So if you submit a job that requires for 8 GPUs for 24 hours, surprisingly, though you requested for more resources, this would actually be prioritized. And but you couldn't do this all the time because then it comes to third factor, which is the fair share factor. This is how much resource you have used in the past. For example, if you've used lots of and the definition of resource is pretty it's kind of vague. It depends on the time you've used it. It depends on the frequency you've used it. It depends on what exact resource you've used. For example, if you used A100, which Colab hates, or compared to if you used a very basic GPU, this resource this resource is sort of you can think of it as compute units, how much compute units you've used in past. And if you use a lot of resource, they would put you in a low priority. And if you used no resource at all, they would prioritize your job. And something to note is that in the fair share, there's sort of a additional factor in the fair share, which is that the impact from you, the longer time before, the impact of the jobs longer time ago has fewer impact than the impact of the job most recently run, which is quite difficult to parse. For example, if you requested for lots of resources a month ago, that would have like minimal impact to what you submit today, compared to if you've submitted an intensive job a minute ago, then it would have a very large impact of how much resource or how prioritized your job is. Yes, the next step. Those are now they're just tips and tricks of how things work under the hood, or how tips and tricks for MSI. So now the next good thing we can set up is the SSH key. Um, to set up the SSH key, We can go to, well, isn't this supposed to be, oh, interesting. Where were we? Yes, I was thinking it should be later in the, let's put this over here. 1 second. Yes. Now let's try to set up our SSH key. Before we set up the SSH key, first it is helpful to introduce the notion of how SSH keys are actually working. Um, Previously, so any in either case would have to set up a secure connection or SSH connection with the server. It is just when we try to say who am I actually and try to authentic authenticate ourselves. When we try to authenticate ourselves, um, there's different methods of doing it. One method is by typing our passwords, which we did during the demo. We would type our UMN password. The other case is saying that, well, I've typed my password before, and you can and I will tell you that you can trust me that I am a good client. You can use another way of authenticating me. Authent I would avoid that word. You can use another way of verifying me. Yes, and that way is through our SSH public key. So you just have a key, sort of like your ID, you show to the server. Well, this is my ID. Look at it. Okay, the server checks, everything's good. And then, nice. We verify you are you, and you can now connect to our server. To set things up, you can follow, there's a detailed documentation in MSI. We're going to walk through how to set things up again. Um, yes, over here we see the MSI official website documentation how to set up your SSH key. The first thing you have to do is that you have to generate this ID you have. You type you type this in your terminal, or if you're on a Mac, if you're on a Windows, type this into your PuTTY software. I don't know how you call it. The extra thing that makes you that make allows you to SSH and connect to the server. You type this into the terminal, and then it would ask, where do you want to store it? And if you type enter, it would just store it in a default file. And then since in my case I already stored it, I wouldn't do it again. But you just type enter, and then you can optionally, actually I should show it. Oh, I do not want to overwrite. Yes, and then optionally you can enter your password. If you just press enter without typing any password, it just means that it wouldn't require any passwords for if the server asks for your SSH key, it wouldn't require any password, and you would just directly give it to the server. Um, yes, so far this is the cool ID you generated. This is the SSH public key you've generated. And then the next step is to tell the server now that, well, I am a good client. You should recognize me. So you would copy your local SSH key, which if you're on the Mac, it will be in the file just now, which is your home directory. Uh, you can just print it, which is your home directory and .ssh uh, .idrsa.pub. This is your public key. You would just copy this over, and then you would have to copy the whole thing over, and then you would go into the server. There is a there's a folder in the server called .ssh, and here you would add your authorized SSH keys over, and this is like your ID. Um, and the third step, which actually I found wasn't required, was that you can follow those SSH key, you can start a SSH agent, which avoids you entering password in the future. But I didn't find I need this step. As soon as I complete the second step, I can connect to the server without typing my password. But you do still need your dual verification. Great. Yes, and if you want to do this third step, this is you just copy the code over and you would paste in your terminal, and that's how you run it. Um, a little bit more into SSH keys if you're not familiar with them. Right now, just now I've shown you guys my SSH public key, which is like the ID the server used to verify, right? Wouldn't that be very dangerous? Maybe. I am not a cybersecurity expert, but so far as to me, it wouldn't be dangerous at all because there's an extra process of verifying your ID. Um, you would send your public key to the server, and then the server would, or the process that happens under the verification is that you would send your public key to the server. The first server says, "Oh, okay, yes, I know you. Um, you are in our database, which is the SSH key, the SSH folder. But how do I know that you didn't copy this from somebody else's tutorial? So then it will send back a challenge problem for us to do. And then this challenge problem, I have another private key where only I have the private key and I can solve the challenge problem. I would solve the problem and then give it back to the server. The server says, "Oh, okay, indeed, you solved it." And then now the connection is established. So there's two parts. One part is for the server to trust me, to see my ID first. And the second part to see that um, I am this public ID, since it's just a string of numbers, it's not copied from anywhere else. It is really that my machine is sending this request. Great. The next thing, just some useful tips of the Slurm script. You can, oh, first of all, the connection between Slurm and MSI. Slurm is this scheduling program that is pretty common to lots of high performance computing platforms. So Slurm is not something specific to MSI. If you search for documentation on Slurm, you would see lots of online resources that is not necessarily generated by MSI. And over here, there's a link to the Slurm cheat sheet, which is like all the possible commands you can run in your Slurm script. However, those are generic Slurm commands, and MSI only takes a subset of them. So, for example, there's some tags or some flags that is supported by the Slurm program, but MSI do not support those flags. Um, that's kind of the relationship between the Slurm script we write and the job we submit to MSI and this whole Slurm program. One useful Slurm feature MSI has, and is the ability to send emails when you finish a job. Here we can see that we can add those two lines to our code. Where you would add them is after you request a resource. The order actually doesn't matter, but by convention, you add it after you request for a resource. Here you finish requesting for all the resource, and here is where you would add like when my job starts, send me an email saying that it starts. When the job fails, send me an email. When the job finishes or runs successfully, send me an email. That's what they all do. I believe you can change this into begin or start error or something like that. But I'll just keep it with all. Yes, and you can see that the job we submitted just now, we would or we should be able to have an email messages from uh we yes, we did have email messages from MSI saying that our job began and our job ended and how long it's been executed. So this is another great kind of logging feature. And if you run the thing for 10 hours and you wasn't logged into MSI and it failed, you can see your email to check if it fails. Yes, and apart from mail, you can also specify where do you want your output file to be. This output specifically is the standard output, which is whatever gets printed to the terminal, you want to redirect it to this file. In this case, you can see that we've indeed redirected it. We've indeed redirected it into the file, which is uh, job log and test transformers with the correct job ID. And you can also do something similar here, which is if anything errors, with error, you can have a shorthand of dash E or dash dash error, and also specify another file over here. You can do exactly the same thing, uh, but let's say um, test transformers error and then the job ID dot log. So now you can view exactly what error happened in this log. Um, nice. Now those are two good MSI's Slurm script features. And let's get into the final two things I want to mention. The first one is let's go through the partitions again. We've only shown a very small subset of the partitions, and we didn't really show what some of those means. We know A100, but we didn't know which others means. We're going to go to the MSI website, and we're going to go to the MSI website and actually, uh, what was this bug? Oh, okay. And actually walk you through how you can read the doc. All right. Here we see that there's a comprehensive list. Oh, that's in the federated partition. We want to go to the A gate partition. Here in the partition, we see that, oh, are you for 5541? For 5541? Oh, are you here for the Oh yeah, I'm still in the middle of the presentation.
Okay, so I was recording it and
Yeah.
I will need to stop the recording soon. Like it will stop soon. So
Oh yeah,
the
when does
last
it stop?
is that what you were expecting?
Oh really? Oh sure, yes. Okay. Yeah, no problem.
Is that
Yeah, well, when should I stop right now or
I can wait. Just let me know when will you be able to finish that.
Oh sure, yes. Sounds good.
Yeah, so if you can tell me right now itself, then you'll be able to finish. I can come back again.
I'll finish it. I'll just wrap it up with a few sentences and I'll finish. Yes. Oh yeah, no problem. Um oh yes, I guess for the Unite students, this is beyond our scheduled time, so I do have to stop. But the Zoom recording will still be recording, and I'll continue the rest with the Zoom recording without Unite. Good. All right, let's go back to the Sturm script. We've just mentioned some good, some helpful Slurm, Slurm techniques or syntax. And oh yeah, we are at the partition already. Yes, here's the list of the available partitions in the A-gate cluster. And we've previously mentioned that the number of GPUs we request for, this really depends on the specific partition we request for. We can see that over here, this was the partition we requested for. And we can see that, oh, let me move zoom away. And we can see that um, it only allows us to request for up to 374 gigabytes of memory per job. It only allows us to request it for up to 24 hours. And it only allows us to request for one node, which is you can think of as one GPU. We can of course look at others. For example, A104. This allows us to request up to 3 days. And oh, actually, that's 4 days. And up to four GPUs at a time. And it allows us to the memory constraint is standard five. Well, still a lot, but particularly the overall time and the number of GPUs you could request. So if you specify A100, you can do it over here. A100 dash 4, and you want to request for four of them, and you want to request it for 3 days. For sure you can do that, but I guess since that's a lot of resource, your job would not be prioritized for a long time after this one finishes. I'll change it back just in case I run it. Um, nice. And then now there's some, and those are, most of them are GPU names. Some of them are weird, like AMD large. There's no GPU as AMD large. There's description over here of what AMD small and, oh, I guess there isn't. Oh yeah, there actually isn't. I believe those are, well, that's out of my knowledge then.
Thank you.
Yeah. Oh, sorry for that. There is Unite coming in again. Um, where were we? Yes, we were getting back to some of the interesting partition names. Um, for AMD large and AMD small, I guess the difference is just in the nodes they have, and specifically with GPU you'd have. I am extremely not sure. Maybe you wouldn't even have a GPU. Might just be pure CPU. Um, yeah. And the two particularly interesting one I want to mention is the interactive and preempt. Those two, uh, oh, I see. And seems like you have them with GPU and with GPU. All right. Um, so those two are the more interesting one. The preempt is easier. For preempt, it is mostly the same as how you submit to a standard partition. However, uh, if you have in your script that the model can save itself when it's being terminated, and it can resume itself when it's being run again, that is a preempt is a perfect option for you. So for preempt, the benefit of it is that it wouldn't lower your job priority, or it wouldn't affect your fair share by so much. And the bad thing is they can stop you at any time, and they would resume you at any time. So say if there's lots of people requesting for GPUs, they would just terminate your job, and then when there's fewer people, they would start running it again. So if your job does have logging of it's does have snapshots of each state they're in, preempt is a great option. Um, and yeah, that's basically preempt. Now we're going into interactive. The interactive partition is provides you, and previously we've seen that it is pretty hard to test our GPU code in our just login node, because over here we do not have access to GPU, and there's no way we could test it. The only way we mentioned that we could test it was to submit the job, and then if anything errors, we debug the error, we submit it again, wait for a long time. With interactive, it becomes good that you can just request for an interactive shell, and just run your code. You will request this by doing um, as run, and I forgot exactly what you would type. Uh, and that's a good time to show you guys how you would figure out some of those commands. You type srun help. Oh, srun is not good. Srun help. This would give you a kind of the flags you can pass in. Um, it's quite a bit, but not too much if you look at some other documentations. And if you ever wonder, like for example, frequency and voltage of the GPUs, maybe this was confusing. There's an even more extensive documentation where you can type man as run. This gives you a very, very comprehensive list of description of what each flag means and what it does. If you ever want to quit this, Control C does not quit this. You'd have to press Q to quit it. In this case, we're just going to run a very easy one. Let's see. I believe the syntax for srun is exactly the same as. Oh, what is happening? Let's see. The syntax for srun is exactly the same as what you would type in sbatch. So, for example, you typed the partition name and number of GPUs. You just type srun, uh, the partition name, which is partition equals to v 100, and the number of GPUs I want. I just want one GPU, uh, and memory I want equals to 20 gigabytes of memory. And the time you do not have to, maybe you do. Let's try it. Time equals to, let's do just 10 minutes, or we wouldn't even need 10 minutes. Let's do 5 minutes. That's it. You would, oh, oh no. Let's see. I think there's an extra argument you have to give, which is which shell you want it to be running in. But I forgot where we have to put it. Let's try it in the very end. Bash. Good. Impressive. So now you can see we're they're trying to set up the interactive session for us. We're still waiting. This is our job ID of our job of requesting an interactive session. Yes, it will take some time if we wait for it for a little bit. And hmm, taking quite a bit of time. Well, while we're waiting for this, I'll just go through the last piece of interesting thing we could have. Um, oh yeah, it is taking a bit of a while. We're going to go through the last very good feature MSI offers, which is um the interactive computing part, or specifically the Jupyter notebook of interactive computing. If you click on this link, this will bring you to the MSI, to a online MSI Jupyter notebook. If you face error at this step, saying header file too large or something like that, go to your Chrome settings and clear your cookies, and that will work. Um, you go over this, and then after verification, it would bring you into, does take a while. Let's see which of them finishes first. All right, apparently this one finishes first. Yes. When you get to here, you will go to interactive apps and you launch a Jupyter notebook. Here you can determine what interface you want, what very interesting Jupyter Python you will want. You don't have to worry about that. Note those you can all keep as default. And which account you want to bullet to, I guess you would only have the option of Professor DK, and how long you want to request it for. I want to request it for 8-bit. Uh, oh, okay, time in minutes. Let's just request it for 10 minutes. And uh, what resources do we want? Um, let's see. Interactive GPU with those resources. Great. With A40. And we can launch our session. Again, this is another job we would submit. They would queue our job until a GPU is available to us. Great. So now we've submitted two jobs and we're waiting on both of them. Um, while we're waiting for it, let's just go through the last wrap up of comparing uh, why would why we would want batch or interactive seems pretty good, and why would we ever want to batch to use an as batch to submit our job, or why do we ever want to submit it through the terminal? Um, Mostly for testing purposes, interactive is very good. Just except that if you do want to specify how many uh oh wow, where was oh I guess it is as good as what was the reason of oh yeah, about requesting for interactive computing. You couldn't specify the GPU type, right? It only gives you a A40 GPU. And with the as batch script, you can actually specify your own GPU type. And uh look at the comments. And that's basically it. This is some error code that you might get from MSI saying that, well, this is the error code, and you can tell from the error code which category of error it was. That this is the table for categories of error code. And now we should be able to get our job. We did not get our job. We get our session. Oh, it is running. Nice. Let's connect to Jupyter. Yes, we submitted this job first, but I guess maybe V100 is much more valuable than A40, or there's just too many people using V100. So the later job we submitted actually got run first. So in here, this is now amazing because they didn't have it previously. Now you just have a Jupyter notebook, just like what you would have, or Jupyter Lab, just like what you would have on your desktop. And you can create notebooks and you can run over here. The only limit is that it is basically a Kodak notebook, apart from maybe moving files is a little bit difficult. But apart from that, you can start any new session. For example, let's start one in the intro tutorial. Let's start a uh oh wow, there's that's a bit too much. Let's start a new file. Um Unintuitive. Let's start a new Jupyter notebook. And if we open in the game, oops, uh, discard. I guess we have to manually specify Jupyter notebook. Okay. Let's first delete the file. And then here, if we want to create a new notebook, oh yeah, here's where we specify. We want to create a notebook with Python version 3.10, and you can just do your standard coding over here. Print yes, you can run it just as how you run, and add cells, delete cells, and everything you can do on everything you can do on your Jupyter notebook, you can do it over here. And plus, you would have Jupyter, you would have what's it called? You would have GPU access over here. I'm actually not sure if it needs me to reinstall PyTorch. Let's try importing Torch, and oh, and seems like all the packages you've installed or all the modules you've loaded in um i- in the bash script, in the bash rc script, actually gets synced over here. So we can see torch.device dot torch available devices, torch.cuda dot is available, torch.cuda dot is available. I cannot spell. Oh, I thought we have a GPU. Um, did did I not request for it? Ah, let's see. Hmm. Well, that's another reason why I guess this is an experimental feature and this is not fully functional yet. So maybe you could restart the kernel and maybe it'll help. Maybe it doesn't. Might be because I could not think of a reason. There's many things that could go wrong. Um, this is maybe another reason, or yeah, why you should maybe use Colab. Uh, but apart from that, everything's all done. That's all I have for the MSI tutorial. This is lasting a bit longer than expected, but I hope it helped. And reach out to me if you have any questions. I could try to help. And then if I couldn't, you can ask MSI. Nice. All right. So thanks for everybody coming here and watching the video. Um, See you.